Hello and welcome to this video lesson of the second derivative and concavity video lesson. My name is Hunter Adams and I'm going to try my best to teach you this. So let's start with concavity. If you look at this graph of cosine of x, you can see that if this is our second derivative, that there's quite a lot of points at which the graph tangent lines like swap. For example, it starts negative. It goes from positive to negative right here, and then from negative to positive, and then from positive to negative, and it just keeps doing. Well, at those points, like those hills and valleys, there's actually a term we use to explain those. It's called concavity. When the graph goes from a negative tangent line to a positive tangent line, then it's a concave up, basically like a U. Whereas if it's concave downward, it's like an N, because the tangent line is going from positive to negative. Now, in between there's actually inflection points. What an inflection point is where the concavity changes signs from positive to negative, or the tangent line. Now, if we're given like an example, if we're given like another example, like first, let's say x to the third. Well, this is misleading about the inflection point because, well, it's halfway concave downward, and then it's halfway concave upward. But the entire time, the tangent line slope is positive. So where this would, it's basically at x equals 0. That's the critical value, and right before that the slope is positive, and right after that it's still positive. So that's a false inflection point. But if we're given cosine of x, oh no, I forgot the mode. Excuse me. You can see that let's say the critical value is whatever this is. Let's say it's just 1. It's not exactly 1, but or negative 1, I should say. But if you look at where, okay, so x equals like negative 2, and then x equals negative 4. At x equals negative 2, the critical value is 0. Well, it's not exact, but I'm just gonna eyeball it and say it is. But before that, it lies in a negative value to switch to a positive value. So this indicates that it's an inflection point and the concavity is changing. So let's look at another example. Let's look at 20x to the third. So the graph is pretty, it's a bad graph to show an example, but I'm going to use this. So let's say if you didn't have this graph, right? Let's say that, oh, sorry, older, I haven't updated this, so. Oh god. 0. Okay. Now let's say that you had the equation just 20x to the third. You have no idea what the graph looks like. Alright. Well, first you'd figure out where the critical value is, and then once you have the critical value, you're gonna put some test values in. So all you know is that at x equals 0, or f double prime of 0 is 0. Alright, so how would you figure out the concavity? Well, you put in test values before and after the critical value. It doesn't matter if it's 10,000 or negative 10,000, as long as there isn't any other occurring critical values there in between them. Alright, so since we just have one critical value, I'm just going to look at negative 1 and 1. At negative 1, the value is negative 20, so that's a negative tangent line. At 1, it's a positive 20, so it's positive tangent line. So if we go from negative to positive, we then have concave down. So it's like halfway. But since the slope is increasing the entire time, again, the flexion point is misleading and it really doesn't have one. Alright. So to do that test value, it's easier just to like make a table. Just make a table, like wherever the critical value is. So if I had a critical value like 3 and 1, well then I would use 4, 2, and like -1 or 0. Whatever's easiest for you. It doesn't matter what the test values are. It's just as long as they aren't like if your critical values are 0 and 3, you're using 4 and 5 as like for 3 using 4 and for 0 using 5. Well, that's misleading since it may have another inflection point at x equals 3. You'd have to use x equals 2 and whatever value you want after 0. And like for 3, you'd have to use 2 and 4, or you'd have to use either 2 and 1, or excuse me. Okay, sorry. Let me. If you're using for x equals 3 and x equals 0, those are the critical values. Alright. Well, for 3 you'd use 2, and for 0 you'd use 1. Just because you don't want to like use any misleading information. You could use 2 though for 0, or 3 and 1, but you can't use like 4 or 3 for 0. For 3 you can use 4, but you can't use anything after 0. Or before 0, I should say. Whereas 0 you have eliminated. Alright, I'm sorry for the last couple seconds, or a couple minute or two there, where I was technical difficulties, but I hope I increased your understanding of concavity and your knowledge of f double prime has improved. Good luck with calculus, and see you in another video, I hope. Bye.